factoring the form ax squared plus bx plus c, where a is not equal to 1. That means the coefficient of x squared is not 1. All right? So I call this method bottoms up. Actually, I didn't name it that. I got it from other people. I don't know who created it, but somebody did, and I'm glad they did because it's what I like to use. I was talking to another teacher about 8, 10, 12 years into my career, and that teacher had won a very prestigious award. In fact, they had won Teacher of the Year for their state. Their entire state, they had won Teacher of the Year. And so I was talking to her, and she said, hey, this is what I do. And I said, oh. I said, I always thought that was some kind of magic number method or something. I didn't know what it was. So I went and changed it that semester in my class, and I went from teaching it in about 2.5 hours to about 30 minutes. So we're going to spend a little bit of time here going over this method. We're going to talk about how to identify when to use this method, because that's the biggest thing I've come up with in my 2+ decades of teaching is we do a good job as teachers, math teachers, of teaching students steps. We do a really poor job of teaching them when to do those steps. So I want to start out with how do we identify when to use this bottoms-up method to factor, okay? Whether you call it bottoms-up or something else, or, I mean, there's a whole, my daughter was taught something called split the middles. I mean, there's all kind of stuff that's out there. But I'm going to use bottoms-up as what I choose. It's what I think is best on all the things I've ever seen. But you may like something better, that's fine. But how do I know when to use it? Well, first off, it needs to be 3 terms, okay? Well, 1, 2, 3 terms. There it is. Ax squared plus bx plus c. Okay, 3 terms. Second, there doesn't need to be a GCF. This needs to be after you've taken out a GCF. Now, for me, I always factor a negative out if there's a negative on the first term. The leading coefficient is negative on everything except difference of squares. All right, so I do that and everything I factor. So when I talk about no GCF, I'm talking about even if the first term's negative, take that negative out, and now you're ready to go if there's not a 1 in the front. So then the leading coefficient is not a 1. That's the third criteria here. So it's got to be 3 terms, no GCF, and the leading coefficient is not a 1. So let's consider 2x squared plus 7x plus 3. Well, how do we factor this one? Well, the first thing we ask ourselves is how many terms is it? It's 3 terms. Look, 1 term, 2 terms, 3 terms, right? It's 3 terms. So check. Is there a GCF? Well, is there anything in common with all 3 terms? And the answer is no, there's not. So guess what? Check. That's 2 of our 3 check marks. And then what is the leading coefficient? Well, it's 2, right? Leading coefficient is the number that's times x to the highest power. So here it is 2, which is not equal to 1. Therefore, check. We checked all 3 of our boxes for do we use bottoms up. So guess what? This meets the criteria we established. It's bottoms up. So let's look at the details of the steps involved with an example. In fact, we're going to use the same one, 2x squared plus 7x plus 3. I'm going to move the leading coefficient 2 to the constant term 3 by multiplying 2 times 3. So notice I've drawn my little arrow here, and then I've put the 2 on it, right? Draw my little arrow and then put the 2 on it. That's signifying moving that 2 over with that 3, okay? So I'm going to do that by multiplying the 2 times the 3 and replacing the 3. Now, if I move the 2, the 2's gone. I'm replacing the 3. So it's going to look something like this. Now we're going to rewrite the transformed. I call it, quote unquote, transformed. Okay? We're going to put the transformed expression with the coefficient of x squared now as what? 1. With 1. That's what's so nice about this. And the constant term is now 6. That's the 2 times the 3. Okay? So, and notice, if you'll notice, I have this cloud here. I use thought clouds for a couple of reasons. One is, in this case, there's 2 major reasons. It's not equal. Those 2 things are not equal. What's in red there is not equal to what I wrote in black to start with. Okay? This, and this are not equal. Okay? They are not equal. So I can't sit there and say, okay, well, that's why I put a thought cloud. They're not equal. And also, if I'm inside my thought cloud, I'm not done. I'm not finished. So that reminds me, hey, I'm not done yet. All right, so let's keep going here. I do this. Now let's factor this. And look, this thing here is the list method. If you need help factoring that, go look at my video on the list method. I have a factoring and list method. That's where the coefficient is 1. So factor using the list method. Remember, you're still in your thought cloud, so there's more to do. And my point is, a lot of times if students don't use a thought cloud, which most of mine don't, they say, this is the answer. all you got to do is FOIL, y'all. X times x is x squared. That's not 2x squared. That didn't work, okay? That didn't work. So if you just start checking it, you find out real quick it doesn't work. All right, so what do I do next? And notice that I wanted the factors of 6 that add to give me 7, okay? So it's either 1 and 6 or 2 and 3, and it's 1 and 6, and that's why I put the 6 and the 1 in here, okay? And then also both positive. That's why those things are both positive. That's in the list method video. All right. Now we undo. Again, this is some little quotes here. We undo the multiplication of the 2 above. So the 2, this 2 is what I'm referring to. Whatever you multiply across, you're undoing that by dividing. And you divide both of these numbers. Both of these numbers came from this 6, and this 6 came from the 2 being multiplied here, right? So divide both of these things by 2. That's what I did here, okay? And then after I divide them by 2, I say, okay, does anything divide out or simplify? Well, this one, 6 over 2, simplifies to 3 over 1. 3 over 1. And the 1 over 2 does not simplify, right? So you leave this 1/2, and here it's 3 over 1, which really, if there's a 1 down here, there's no longer a fraction, right? There's no longer a fraction there. So what do I do after that? Well, this is why it's called bottoms up. I take the 2 that's left over here and I move it up in front of the x, but inside the parentheses. Inside the parentheses, but in front of the x there. I bring it up. That's the bottoms up part. So this 2 is now this 2, okay? When I bring it up, it's no longer under the 1. And this parenthesis stayed x plus 3 because there was nothing in the bottom to bring up, okay? So x plus 3 times 2x plus 1, and I want you to notice something. This is not in my thought cloud because this actually equals this. All right, so I was able to transform it, and then here, when I divided and simplified, I transformed it back. I transformed it back into its original form, or so that when I multiply, not a form, but when I multiply this by FOIL, right? So what can I do to check it? You can always check factoring by multiplying. In this case, you FOIL. So if we just mentally go through this, what is x times 2x? 2x squared, bingo. Then we have x times 1 is 1x, that's plus x. And then this gives me plus 6x. And x plus 6x is plus 7x. That worked out. And then what is the last thing here? 3 times 1 plus 3. All right, so we just briefly went through it in our head and checked it. It worked out, okay? So let's work some of these. Let's work several of examples of these. In fact, I'm going to work a few, and then I'm going to work some that have a GCF first, but then after you take the GCF out, you can still use bottoms up. Because remember, anytime you learn a rule in factoring, every time you learn a new rule, anything you already know is fair game, right? It can be rules stacked on top of each other and all that kind of stuff. So here, I have how many terms? 1, 2, 3. 3 terms. Do I have a GCF? No GCF. Is the first leading coefficient 1? No, it's not. That means this is bottoms up. I know this is bottoms up because I just identified it as such, okay, with those 3 criteria. Not a 1, 3 terms, and no GCF. So that means I'm going to have a thought cloud. And in my thought cloud, I'm going to take the 3 times the 4. So then it becomes x squared plus 13x plus 3 times 4 is 12. All right? And then I'm going to factor this thing with the list method. Okay? So we're going to say x, and I need the factors of 12, 1 and 12, 2 and 6, 3 and 4. The factors of 12 that add to give me 13. All right? Well, 1 and 12 add to give me 13. So 12 and 1, doesn't matter if you put the 1 first or the 12 first, just get the signs correct. And now let's go back. My signs, they're both positive. That plus 12 tells me they're the same thing. They're both, whatever that first sign is in front of 13, in this case, both positive. All right, so now I factored that with the list method. That's a lot easier to factor than with a 3 out front or a 2 out front or a 5 out front, anything out front for that matter. All right, so now I need to go, okay, I need to go back and undo this multiplication of 3 here. How do I do that? Well, I divide this by 3 and this by 3. You always do that. You always divide both those numbers by whatever you multiply by. In this case, 3. Does this part simplify 1 over 3? No. So that bottom comes up. So when I write it down, it's going to be 3x plus 1. That's the bottom that came up there. Here, does this simplify? Yes, 12 divided by 3 is exactly 4 over 1. Since there's a 1 down here, what if I bring a 1 up here? What is 1x That's the same thing as x. We don't write it. We don't write the 1. That's just going to be x plus 4. Okay? X plus 4. So 3x plus 1 times x plus 4. And that, if we FOIL that out, we end up with what we started with, right? So that is our bottoms up there. Okay? So I always have my thought cloud. I go in, do my list method, then I go back and divide, that kind of thing. So let's look at another example here. So 3 terms, no GCF, and there's not a 1 in the front, right? So I'm going to take that 5 and I'm going to multiply it by the what? By the 3. And I know I didn't put it down here this time. It doesn't matter if it's above or below. There's nothing magical about that arrow. Okay? It's just the way I denote it. Somebody else that does bottoms up may not denote it that way. All right? So then, here's my thought cloud. And in my thought cloud, I have y squared minus 16y plus 15 now. Okay? So I have 1 and 15 because I'm going to factor it. Let me go ahead and change colors actually. I'm going to factor it. So I have 1 and 15 or 3 and 5. There are no other choices. I want the factors of 15 that add to give me 16. And I'm going to come back to the negative. Don't be screaming about the negative. All right, y and y. I treat my signs separate. I have rules for all this, and you always work. So go back and watch that list method video. They never, ever, ever fail. That's the best thing about them. 1 and 15 add to give me 16. So this time I'm going to put the 16 first. It doesn't really matter. Okay? 16 and then I'm sorry, not 16 and 1. That's not what I write down. I circled 15 and 1. 15 and 1. 15 and 1. And the signs here, if this is a positive, they're the same. They're both this sign right here. So they're both negative. So minus and minus, or negative and negative. And then I have to go back and do what? I have to undo multiplying by that 5 by dividing by the 5, right? So divide this by 5, divide this by 5. And then, let me change the color here. Divide it by 5 here. So I'm going to divide this one by 5 and divide this by 5. Does 15 over 5 simplify to 3? Yes, 3 over 1. So is there anything that comes up in front of the y here? No, it's just going to be y minus 3 equals, all right, in front of it, equals. Excuse me, I had to cough. And then here, y minus 1/5. So the 1/5 doesn't simplify here, right? So I need to take this 5 and bring it up. So it's going to be parentheses 5y minus 1, close parentheses. So y minus 3, 5y minus 1. All right, for this problem, 3d squared minus 13d minus 10. There's 3 terms, right? There's no GCF, and the first term is not a 1. So we're going to take this 3 times the 10, or times the negative 10. We're going to have bottoms up here, right? So in my thought cloud, come on here, my thought cloud. I'm going to have d squared minus 13d minus 3 times 10 is 30. Minus 30. And then I'm going to take my factors of 30, 1 and 30, 2 and 15, right? 3 and 10 is how I found it. 4 doesn't work, 5 and 6, and then I'm back to where I started. So d and d, factors of 30 that subtract to give me 13. I got to be careful. 10 plus 3 is 13, but this says subtract. So 15 and 2, right? 15 minus 2 is 13. So put in here my 2 and my 15, and it doesn't matter what order I put those in. What matters is I get plus 2 or minus 2 right, and plus 15 or minus 15 right. My signs, this says they're different. I don't mean in the problem. I mean a minus says these two things here are different. Okay? So they're different. I read it out loud. As bigger number gets that sign. So 15 is bigger, so it gets that sign, which is negative, and 2 gets a positive. And then I go back and do what? I have to undo my multiply by 3. I got to divide by 3 here. So 2 over 3, that does not simplify. So you bring this 3 back in front of the d, and that parenthesis becomes 3d plus 2. This one, 15 over 3, 5, right? 3 goes into 15 5 times and 3 once. There's nothing to bring up here, so you don't worry about it. That just becomes what? D minus 5, okay? So this is d minus 5. D minus 5, all right? So 3d plus 2 and d minus 5. 6x squared minus 19x plus 10. So I have 3 terms, no GCF, and not a 1 in the front. So I'm going to take the 6 times the 10, and that's going to give me in my thought cloud. Okay, let's come in here in my thought cloud. x squared minus 19x plus 60. And so now it becomes a list method, and I want to list out my factors of 60. 1 and 60, 2 and 30, 3 and 20, 4 times 15, 5 and 12, 6. It's a long list here. And you don't have to always write those out, remember, okay? If you can find it right off the bat. I like to list them out to make sure. So I want the factors of 60 that add to give me 19. Well, the ones that add to give me 19 are 4 plus 15, right? That's 19. So if I come over here, x and 4, x and 15, and both signs are negative. Both signs are negative, so both negative. And then I come in here and say, okay, I need to go back and divide by what? I need to divide by, what did I multiply by? 6. So divide both of them by 6. But this time, 4 doesn't divide into 6, or 6 doesn't divide into 4 evenly, right? But they have something in common, right? If they have something in common, what do? I factor out what they have in common. So these have a 2 in common. 2 goes into 4 twice and 6 3 times. That 3 comes up here. So this is going to become 3x minus 2. So what you need to remember is this entire 6 will divide out of these things. It just may divide out as part. Like this one divided a 2 out. So guess what? This has got divided 3 out because 2 times 3 is 6. Okay, it's got the whole number's got to divide out the whole 6 with the entire 6. We only divided 2 out, so 2 times what is 6? 3. So if we look over here, what does this have in common? It has a 3. Okay, you don't have to know that to do this. You can just look at it, but make sure you simplify it. 3 goes into 15 5 times, and 6 2 times, and that 2 comes up here. So then that becomes what? 2x minus 5. 2x minus 5. 2x minus 5. So 3x minus 2 times 2x minus 5. If you FOIL that out, you end up with 6x squared minus 19x plus 10, which is what we started with. All right. What about this one? Is it bottoms up? Well, it's 3 terms, but oh, wait a minute. Even number, even number, even number. If all my numbers are even, what do I know for a fact divides out of all those? A 2. If every number's even, it's divisible by 2 every time, all the time, every day, all day. Okay, so if that's the case, then I need to first do a GCF of 2. And then I'm left with 2x squared plus 5x plus 3. And I needed to say this. Is there anything bigger than 2 that divides out? And there's nothing there. So 2 comes out, and then I'm left with this business in here. And that is 3 terms without a GCF and not a 1 in the front. So guess what? It becomes bottoms up. So I'm going to leave this as 2, and then I'm going to have 2 parentheses here, and I got to figure out what they are because this part is now bottoms up. Okay, so I'm going to say the 2 times the 3. Oops, not a 3 there. I multiply the 2. All right, so then I'm going to come out here to my thought cloud. I'm going to come out to the side this time. It doesn't matter where you put your thought cloud, just wherever I have space. So this is going to be x squared plus 5x plus 6. Okay, but the key is I had this 2 out here. Don't forget it's still out there, right? Now, if this doesn't factor any further, then this is my final answer, right? So, but this one's going to go further with bottoms up. We have, to factor this, we have 1 and 6, 2 and 3, and I want the factors of 6 that add to give me 5. You got to be careful. You don't want 6 minus 1, you want 2 plus 3. So x and 2 and x and 3, and then they're both positive. So plus and plus. And then I come back and say, okay, divide both of them by what? 2. 2 over 2 becomes 1. This one doesn't simplify, so we bring that 2 up front. So this first parenthesis is x. You know what? I have it over here. This is x plus 1 and 2x plus 3. Right? This one is x plus 1. There's nothing left down here but a 1. And then this one is 2 comes up as 2x plus 3. So here is our final answer for that one, okay? It had a GCF of 2, and then the remaining trinomial, the remaining 3 terms, the 2x squared plus 5x plus 3, factored using bottoms up. So we had a GCF followed by bottoms up. That happens. It happens. You just got to be ready for it, okay? So here, 3 terms. Is there a GCF? You might say no. And then there's not a 1 in the front, but because this leading coefficient is negative, to me, it is much more difficult to factor when there's a negative there, okay? So if I have a negative leading coefficient, I always, if nothing else, I factor out a negative. So here, I'm going to say negative, and then this is going to be 3x squared, and if I take a negative out, remember, that changes all my signs. So minus 13x and then plus 10, okay? 3x squared minus 13x plus 10 in my parentheses with the negative out front. So then when I come down here again, minus, and I'm going to have two parentheses, and I'm going to come over here in the thought cloud. This part here is bottoms up. 3 terms, no GCF, and not a 1 in the front. So take that 3 times the 10, and this is going to be in a thought cloud. X squared minus 13x plus 30. And my factors of 30 are what? Because I need to factor that now. 1 and 30, 2 and 15, 3 and 10, and 5 and 6. 4 doesn't work. And I always go in order too, right? So again, I explained this in the list method video. So the factors of 30, I want the factors of 30 that add to give me 13. You got to be careful because 15 minus 2 is 13, but 10 plus 3 is 13. So which one is it? Well, it's 10 plus 3 because I want the ones that add. So I pick 10 and 3. So I have x and 10 and x. And it doesn't matter, again, if you put the 10 or the 3 first. What matters is you get the plus 10 or the minus 10 right and the plus 3 or the minus 3 right, the sign that goes with each number. Here, this says they're the same. I don't say that out loud. In my mind, I say same out loud. I go, they're both negative. Both negative, negative, negative. All right? But I'm not done. I have to do what? Divide both of them by 3, which is what I multiply by. Does this simplify? Nope. So bring that 3 up here, and that becomes 3x minus 10. And then this one, that becomes a 1. So what does that parenthesis become? X minus 1, right? There's nothing to bring in front of the x there, so it's just x minus 1. Don't forget the negative is out front, and now you are done factoring that one. You are done factoring that one. So 24x to the 4th plus 10x to the 3rd y minus 4x squared y squared. Are you kidding me? I know this is one of those where I said, let me just come up with something crazy and see if we can do it, right? So how many terms is it? There's 3. 3 terms. First thing I always ask myself in factoring, is there a GCF? Okay? So, and if it's not one, and there's not a 1 in the front, then I use, bottoms up. Here, there's a GCF. What is it? Well, they're all even. Is there anything bigger than 2? No. So 2 goes into all of them. And also, there's x to the 4th, x cubed, and x squared. Remember, if you have a variable, the same variable in every term, you take the smallest power out. So this is x squared, 2x squared, and I'm left with 12x squared because I took 2 of them out and I had 4, so I got 2 left, right? And then 12x squared plus 5xy. I didn't take the y out. Got to keep the y there, right? And then minus 2, and I took both x's out, so I'm left with just y squared. So now I have 2x squared and then all this other stuff in parentheses. And all this other stuff in parentheses. This is 3 terms, no GCF, and not a 1 in the front, so it's bottoms up. Okay, and I forgot. I need to also leave what out front? My 2x squared, and then have my 2 parentheses here. So I'm going to take this 12 and multiply it by the 2. The 12 times the 2. And in my thought cloud, right, and you can see what I'm doing here. I'm also incorporating x squared and a y squared and an xy in the middle. So look, this is x squared plus 5xy minus, not 10. I don't know where I was doing the 5 times 2, I guess. 12 times 2 is 24y squared. So when I do this, when I want to factor this, I have x and y, right? As long as you have both the variables in the middle and you have x squared first and y squared last, your x's come first and your y's come last, okay? That's how that works. So then I want the factors of 24 that subtract to give me 5. And you may already know what they are, but I'm going to list them. 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And 3 and 8 are them, right? So 3y and 8y. I want the factors that subtract give me 5, and I want a bigger number. This is bigger. In my mind, I say they're different, but out loud, I go, bigger number gets a plus. Well, 8's bigger than 3, so 8 gets the plus. And since they're different, 3 gets a minus. But I'm not done. I have to go back and do what? Divide by that 12. Okay, divide by that 12. Do 3 and 12 have anything in common? Yes, 3. That's 1 over 4. Bring that 4 up, and what does that parenthesis become? It becomes 4x minus 1y. 4x minus 1y. All right? And then what about 8 and 12? Well, they have a 4 in common. 4 goes into 8 twice. 4 goes into 12 3 times. Bring that 3 up, and that becomes what? 3x plus 2y. Okay? So that one had the y squares and the y's in it. It also had a GCF, and it would look kind of funny and crazy. Look, if you can do this one, you can do just about any of them. Okay? So look, you can stack these up. These can be crazier, harder. You can have other things involved. Anything you know in factoring is fair game. You can stack them all together. I just wanted to show you a few with the GCF before you did the bottoms up. Okay? But the big idea of this video is the bottoms up. I hope this helps you factor. Good luck with factoring.